Greetings and welcome, friends. How are you doing today? I'm doing great. I'm just looking for my pen here. I found it. Check this out. We're talking about compound inequalities. Compound is when you've got like more than just one thing going on at a time. Compound inequality is an inequality formed by joining two inequalities with the word and or the word or. They just used or twice. That's funny. So a graph of a compound inequality with the word and is the intersection of the graphs of the inequalities. So notice here is x greater than or equal to 2. That would go forever. Here is the graph of x less than 5. That goes forever to the left. And the and logic, what that does is it considers when are both of those true. All right, when are both of those true? And both of these are true only for these common spots, right? And so that's why it's the intersection, the logical intersection between both of those things, right? All right, so how about the or operator? Now, or means that only one of those things has to be true at a given time. And so notice, like, when I say is -3 a solution of this, -3 works for this one, but -3 does not work for this one, right? But I don't care that it doesn't work for this one. I'm using the or logic, and or just means it needs to work for one of them, right? So notice that it worked for one, so it works with the or logic. Here it had to work for both, right? Here's something that worked for this one, but it didn't work for the other one, so notice it wasn't a solution on their and compound inequality. All right, and notice this. If I look at 0, here's 0, not a solution of that one. Here's 0, not a solution of that one. And that's why it's not a solution of them combined when I have the or operators. So these are two types of compound, pound it, right, inequalities. And let's see if we can do some work with these together. Example 1. Example 1. Let's see. Write each sentence as an inequality. All right. It says the number x is greater than -8. Keyword and less than or equal to 4. Nope. This one graphically will be shaded in between. When it's an or, it's shaded away, is the way that, like, 98% of the time, that'll be how it works. All right, so x is greater than -8. So watch, I'll even write this in pieces. X is greater than -8. And then the next part was x is less than or equal to 4. Now with an and operator in between those, I'm going to write this like so. Ready? Watch this. I'm going to write this as -8. I'm going to write it from least to greatest. -8 is smaller than x, right? Is that true? If x is bigger than -8, that means -8 is smaller than x. And x is less than or equal to 4. Okay? So when I write an and compound inequality, I write it from least to greatest. And since I'm doing that, Amity, I'm going to write these with all, notice least to greatest, these are all types of less than signs. Least, less than, right? And then I write the smallest thing, the mediumest thing, and the largest thing. Okay? Graphically speaking, for that, I'm gonna need 0. I'm gonna need -8 on my number line, and 4 is closer to 0 than -8 was, twice as close. And so I'm going to graph, when it's an and logic, it's shaded in between. So -8 had the less than sign, so it's an open circle. You with me, Ethan? A closed circle at 4. And it's shaded everywhere in between. Bing, bing, bing. There we go. All right, so that's part A over here. Let's do part B. A number y is at most 0. So that means y, if y is at most 0, that means it can equal 0, but it's never going to be bigger than that. What's the opposite of bigger than, right? That'd be less than. So y is going to be less than or equal to 0. And then how do I interpret this, Amity, if I have y is at least 2? Okay, Adriana with the alley-oop. All right, so if it's at least 2, that means it can equal it, and it's got to be bigger than that as well, right? Bigger than or equal. So now this is how I'd write an or compound inequality. That's how those come together. I don't have a way to like write them all as one, like I did with the and. And when I graph these on a number line, or will be shaded away from one another, okay? So I'm going to have, let's see, looks like 0 and 2 are my points of interest here. My number lines are super simple. I'm not looking for anything that complicated. If you want to throw some more like tick marks in there, you can, but I just care about the points that are interesting to us. Well, just like I did. Are you talking about the variable? Yeah. Okay, well the variable is represented, that's actually a really good question, by the shaded region. The values of x that make this inequality true are everything that's shaded, all right, on the number line. Everything up to -8 from the right side and everything up to and including 4. So the x is represented by all of the green stuff here on my graph. All right, I see your question. So let's see, y is less than or equal to 0. Closed or open circle, Jimmy? What do you think for this part? Closed or open circle? Closed, yes. It's a solid dot, closed circle, because of the equal to part. And let's see, Ethan, which way do you think I shade this? To the left, right? Less than is to the left. I agree. So that's half of the graph. Now the other half, Pooja, how do I graph this part of it, the or compound inequality? Is it going to be a closed? So it's going to shade to the right, yep. And it's closed or open? Closed, and at which number? At the 2, yeah, right? So closed and shaded that way. And notice that the or graphs will be shaded away from one another. All right, actually that's like a good, maybe we'll even write that down. Or away, all right, and is in between. Together? All right, we can write together. Look, oh dear, I zoomed out. Here we go, I'll fix it. Bam. There we go. We'll say and together. Actually, that makes a whole lot more sense. And is everyone's together. I like your explanation. I like it. Yeah. Can't disagree. So let's do example 2 together here. Oh boy, now we're going to solve compound inequalities. All right, don't worry. We'll do it and style. We'll do it together. All right, solving compound inequalities. Now, I'm going to say, let's pretend, if I wanted to solve this compound inequality, this is an and inequality, let's pretend that this part wasn't here for a minute. You don't have to scribble it out on yours. I'm just scribbling it out on mine. How would I solve this one? Add 2 to both sides. But wait a minute. There's 3 sides now. What do you guys think I might do? Like just a complete shot in the dark. I normally would have added 2 to both sides. Add 2 to all 3 sides, right? It's crazy enough. It just might work. I think it will. All right, so -4 plus 2 is -2, less than. X is now by itself, which is less than 5. Solved. Solved it. And let's see, to graph this, let's see, this is, notice the X is in between the numbers, so the shading is going to be in between the numbers -2 and 5. Notice I make the 5 further away than the -2 from 0, right? And let's see, this will be open circle, and together now. Did I at least give you guys number lines on your paper? You're welcome. Although you don't, you know what? This is such a good number line. I'm gonna sign this. Bam! Look at that. That's like an authentic Waddy number line right there. So unique, you'll never see one like that again. Wow. All right. Oh man, look at this one. What's going on over here? What do you guys think I would do if I'm trying to get x by itself? What would I do? Subtract 1. Dividing is allowed, but it would create fractions. All right, so that's the only reason I don't like it. But if you are a fan of fractions, you could just be like, I'm going to just divide. And instead of just subtracting 1 from both sides, Devin, what should we do? Subtract it from all sides. Everybody is getting taxed $1 today, right? That's everybody. Doesn't matter where you are. -3 minus 1 is -4. Less than -2x. Oh, these ones canceled out. Is less than or equal to 8. Uh-oh, multi-step. Now what do I do? Divide everybody by what? Better yet, -2. And wait a minute, guys. We just said the magic words. We said divide and negative. Bong, 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 bong. We have to flip those signs. And we flip all of the inequalities, friends. All of them. So let's see. -4 divided by -2 is +2. X is by itself in the middle. And 8 divided by -2 is -4. So notice I flipped all of them. But let's do the thing where we rewrite this from least to greatest now, because notice it's no longer in that order. Okay. So how could I rewrite this in least to greatest? Yeah. Okay, this sign, if I was to mirror this entire thing, this inequality is now over here and flipped again. Good catch. So less than or equal, right? And the less than sign's over here. So the entire thing got flipped to write it from least to greatest. Right? See, today's lesson, it's not that different from what we've been doing. It's just like, hey, what if you did 2 problems at one time? And then that's all we're doing. Simultaneous solving here. And let's see, this will be solid at the -4, open at the 2, and in betweeniest. Which, by the way, my wife is the second of 5 daughters in her family. 1, 2, 3, 4, 5. Right, so here's the youngest, the oldest, the middle, and since she is this, I call that the in-betweeniest. She's the teeniest of the in-between kids. And this I would call the in-betwoldest. In-betwoldest. Those are just completely made-up words that I... Yeah. And then there's now 13 cousins that they all have. Their family has ruined birthdays for me. So I can't celebrate birth this much, friends. It's just every month there's another person's birth, too many birthdays. I can't handle it. And so I'm sorry. I've become a birthday Grinch. I'm sorry. Someday, my heart will grow 3 times, and I'll be as strong as 10 Grinches plus 2, and it'll be amazing. But it is not this day. Okay. Now, the OR ones are even easier. You just solve this one, and then you solve that one, and then you graph them together. All right. So watch this. I'm gonna cruise through this one, because you guys know how to do this. Add 5. Ready? So this is example 3. Write it down if you can. 3y is less than -3. Oh, Cameron, when I divide by 3 here, do you think I need to flip this inequality? I'm dividing by a +3, but there's a negative there. No, right? No, because dividing by a positive is fine. It's only when the bottom number is negative that I'd have to flip it. Okay, so y is less than -1 is the first part. And let's solve this side separately. We'll add 1, add 1. Might not have much space with these being so close together to each other. 2y is greater than 6. It's a sad looking greater than sign, but it's okay. We're just gonna, we'll cheer it up later. Divide by 2, divide by 2. Jimmy, do I flip the sign? No, because I'm dividing by a positive. And guys, check this out. I've got 2 answers. I have OR logic up here. I just throw an OR in between there. And then I box it. Let's graph this. Graph it. Right, this is not that scary. How are you feeling as far as scariness scale of 0 to 10? A 4? Okay. 6? Okay. All right. Okay. All right. Let's graph this. Ethan, how do I graph this part of it? I like it. Let's see. Devin, how do I graph this part of it? He said open circle, and I agreed with him. And then he said shade it to the right, and I liked that. I liked that. And notice, OR usually shades away from each other, right? Those two are just like, I am going this way, and you are going that way, and I never want to see you again. I'm going this way until negative infinity. And they never see each other again. It's kind of sad. All right, I think I would rather have you guys get some practice going, so that's what I'm going to have you do. Have a good day, internet friends. Adios.